All right. So again, this chapter is going to cover a lot of vocabulary, and the idea is it's going to be some of it will be review, some of it will be words you've already heard before, but we're actually going to basically define them in more detail. For example, like diameter, like you've seen diameter before, elementary school, middle school. It's just this um, a line segment that goes across the circle and hits through the center. Okay. But we're going to actually define it with different words. I'm actually going to use the word chord, which you may or may not remember, to define it, right? So pay attention to those small details of this lesson. Don't gloss by. Oh, I know what diameter is. What you do, but there's going to be more detail with that. And kind of part of the reason for that is that when we get into more advanced math, that if you are familiar with like the words of it, you're going to have a much better experience and be able to do more advanced problems. Um, a lot of it right now, you can kind of think of this as learning a new language, right? So when you first knew a new language, a lot of it is just you have to learn words, right? So like if you're in Spanish, you kind of need to start, how do you count uno, dos, tres, cuatro, cinco, seis, right? You have to learn the words, and then from there you can construct sentences and start communicating. So similarly, before we can really start constructing more complex problems, we need to kind of have a basis for all these words, what they mean, and not just there's that part of it is what do they mean, but also how do you mark them, right? In math, you're going to have lots of shapes, and how do you mark them? How do you write them? And so on and so forth. So let's go ahead and start with a circle, right? So we all know what a circle is. It's a little round thing that you see like on a wheel. And the silly thing won't erase. Hold on. Okay, there we go. All right, so a circle is basically, well, it's this, right? It's a round shape like you would see with like a pizza or a bicycle wheel. And as you know, if I have a dot at the center of the circle and it goes out, that's called the radius. And then the point here, that's called the center. And this is a circle. Okay, but in this book, we need to define a circle using words we've already defined. And we've already defined a point, and we find that a circle is basically, if you can imagine like a bunch of points over here, that if you have a bunch of points that are all the same distance from the center and you have an infinite amount of points, that eventually you would have a circle. And that's how in this class we're going to define it. Okay, so it's a bunch of points that are the same distance from the center, and that's going to be a circle. And the given distance that we have in that definition, we're going to give it a name. We're going to call it the radius. And the point in this is we're going to call it the center, the point in the center. And typically that point will be labeled, sometimes point O, other times point P, but we're going to call it point O. And there we go. All right, now again, in this class, you've been practicing a lot with definitions, how to define things. To review, the first thing we're going to do is classify and then differentiate from other things inside that class and look for counterexamples to make sure that our definition is complete. All right, so starting with a chord. So here are two pictures of what a chord is and then two pictures of what a chord is not. So the first thing we're going to do is classify it. So it looks to me like a line segment. And what I notice about this is the endpoints of that line segment are located on the circle. So the endpoints are on the circle. So we could define it as a line segment where both endpoints are located on the circle, or both endpoints intersect the circle. Finally, next you have a diameter. Now you know what a diameter is, right? It's a line segment that crosses a circle, hits the center. When we could define it that way, we could say it's a line segment, and both endpoints are on the circle. And it looks like the segment intersects the center of the circle. Or we've already defined a chord in the previous definition as a line segment that has both endpoints on the circle. So we could actually just say it's a chord that intersects the center of the circle. So both ones are good. All right, here's a word that may or may not be new. It's called a tangent, and a tangent is a line. So we're going to classify it as a line. And how do we differentiate it from other lines? Well, if you look at it, it appears as though it intersects the circle at one point. So it intersects the circle at one point. And we'll notice here too that it is important to say it's a line, because you could have something like this ray right here that intersects it at one point. But if it were to actually keep going, then it would intersect it at a second point. See, so imagine it's a line, but it's okay. I mean, you're going to see situations like this where you have a line segment that intersects it at one point, and when it looks like that, it's still called tangent. Okay. All right, some more vocabulary here. So if I say that two circles are congruent, that means they're the same size. So, but how am I gonna determine if two circles are congruent, right? So let's say I have a circle here and a circle here. Well, then how would I actually indicate they're congruent? Well, if I just mark the radiuses the same, then those are going to be considered congruent circles. Remember, we can't assume in geometry, we can't assume that anything is congruent unless it's marked congruent, not just on how it looks. So like these CDs right here, they're the same size, but we can't assume they are in this class unless each radius is marked congruent. Another word you'll see is concentric circles. That's kind of like a bullseye here, like these arrows, where you have a bunch of circles that are getting bigger and bigger and bigger, but all those circles have exactly the same center, and those are called concentric, same center. Kind of like when you're, you have like a drop of water on a pond, and like you have these ripples that go out, that they all have the same center, right? That point where the little drop hit the water and goes out. Those would be concentric circles. You can also have things that are, you can actually inscribe and circumscribe polygons about a circle, right? So here's an example of a circumscribed circle. Now what that means is that this blue circle here is circumscribed around this triangle. Or here's another example of a circle circumscribed around a quadrilateral. Right, so circumscribed about a polygon. Or I can go ahead and draw the circle inside the polygon. And the way I talk about that is a inscribed circle. Right, so if I have a circle that's outside the polygon, it's circumscribed, or outside. And then when it's inside, it's inscribed, which is kind of nice that they use that word. So inside is inscribed circle. Outside is circumscribed circle. All right, now here's some very important terminology, and we'll go over this again when we do the circle chapter later on in the book. But in circles, we need something to call a part of a circle, right? So if I have a circle here, I know that the entire measure of the circle is 360 degrees, right? So an entire circle is 360 degrees. And then half of that circle would be what? Well, it'd be 180 degrees. And then a quarter of that would be 90, and then eighth would be 45, and so on and so forth. So that measure of part of a circle is called an arc. Okay, so if I have like, half of a circle, which is 180 degrees, the way I'm going to say that in math is I'm going to say the arc measure of that piece is 180 degrees. Or if I have like, a smaller piece that's say like an eighth or 45 degrees, then I'm going to say the measure of that arc is 45 degrees. In addition, there's different names. So if you have like a bigger arc that's like more than half a circle, I'm going to call that a major arc. If I have a piece of a circle that's less than 180 degrees, I'm going to call that a minor arc. And then if I have an arc that's half of a circle or 180 degrees, I'm going to call that a semicircle. Okay? So again, we're just kind of familiar that when I start using these words in class, it's going to be really important to have an idea or a picture in your mind of what I'm talking about, right? So if I say minor arc, have a picture in your mind of a piece, a smaller piece of a circle. If I say major arc, have a picture in your mind of something that's more than half a circle, a larger arc. In addition, it's, there's mathematicians, they like to kind of abbreviate things a lot to kind of save time. So with with a line segment, if I say line segment AB, it gets really cumbersome to write LINE SCGMENT AB every single time. So mathematicians use shorthand with AB with a line on top. And the same thing with arc is a lot of the reason for this is mathematicians a lot of what they do is proofs, and so they're writing a lot of different things over and over and over again, and so they start to use these abbreviations because what they care about mostly is the ideas. And so like if I have a minor arc, PD here, right, I can go ahead and indicate that with a little arc shaped thing on top. And that basically says, here's a minor arc, here's PD, right? Now, if I have a major arc, and that means I'm going to have to go the other direction, right? The longer direction. So how do I indicate to my reader that I'm referring to a major arc if I don't actually use those words? Well, it turns out if we just use 3 letters like PAD, that's going to tell the reader, oh, I'm referring to this major arc, this longer piece of my circle. Okay. So again, this is just a shorter way of writing minor arc and major arc. And if I have a half of a circle, I'm also going to use 3 letters so that I know which half of the circle I'm talking about. Otherwise, the reader's going to have to guess what he's talking about, the bottom half or the top half. So I'm still going to use 3 letters for a semicircle, little arc on top. Okay. All right, now there's an interesting relationships we see here, and okay, so this is great, but let's say I have a circle and they're asking me for the arc measure. Like, how do you measure an arc, right? Because it's a piece of a circle, and how in the world are you going to measure that? Well, it turns out that if you get your protractor and you put the vertex right here and just measure this angle here in the center of the circle, that's actually going to be the same as the arc here. So if I just measure that central angle, that'll tell me the arc. Like, for example, if you have half a circle here and I just go ahead and measure that, I'm going to get what? I'm going to get 180 degrees, which makes sense because half of a circle is 180 degrees. Now, of course, as mathematicians, we want to name everything, right? So that we know what we're talking about. So if I have an angle that has a vertex at the center here, then I'm just going to call that a central angle because it's at the center of the circle. Kind of makes sense. So call that central angle. And let's do a little bit of review here. So if I use the word reflex measure of an angle, what's the difference between the measure of an angle and the reflex measure, right? Well, the reflex measure is basically the longer way or the longer, bigger angle. Okay, so for example, here's an angle, and the measure of this angle will be 45 degrees. Okay, the reflex measure is the longer distance here, which is 315 degrees. So again, just some words so that when I start using them, you're kind of familiar with what I'm talking about. All right. Here's a couple summary questions. And let's go ahead and do this example so we can practice drawing it, okay? So again, here's an example of, I'm just going to be starting to use some words that we've defined and then asking you to draw it. So go ahead and sketch 2 circles. Okay, so let's do that. sketch 2 circles. 1, 2. And it says they have to share a common radius. Oh, so how are we going to do that, right? So here's a couple circles. Just draw a little line here. Now, if they share a common radius, that means I'm going to have to take this center and kind of overlay it over the other center. And then they're going to go ahead and share the same radius. So let's do that. I'm going to draw a circle here. And then draw another circle like this. And so if they share a common center, like that, then they're also going to share the same radius. And that's only going to work, of course, if the circles are congruent. And I think really probably one of the best ways to visualize this would actually be to cut out 2 circles, and then you can kind of lay them on top of each other, and you can see that in order for this to work, the center of this circle is going to have to intersect this circle right here. And then the center of this circle have to intersect that circle. But again, a lot of this is visual, right? So if I'm talking and explaining it and you're not really following, that's totally fine. And so just get 2 circles out and overlay them, and you'll kind of see what I'm talking about. We're going to go ahead, and then it says sketch 2 circles. All right, let's go ahead and do that. So sketch 2 circles. And they're going to share a common chord and a common tangent, right? So again, this would be a point where you're like, what's a chord again? What's a tangent again? So you can go back, look at your definitions, kind of remind yourself of what they are. So again, a chord looks like this, has 2 endpoints on the circle, and then a tangent hits the circle at 1 point. Okay, so going down over here, we have, so we'll sketch 2 circles that share a common chord. So here's a chord for one circle, and here's a chord for that circle. And they share a common tangent, right? So here would be a tangent here and a tangent here, right? So how would I then take these 2 circles, combine them together so they share the same tangent and they share the same chord? Well, what if I were just to kind of move this point and intersect it right here, right? So take this point and put it there. And then I could take this point and put it here, and then kind of reorient the circle so that this tangent, let's see here. So this tangent and this tangent were collinear, right? So there's another word, collinear. What does collinear mean? Well, if I have this line here and that line there, collinear would mean they kind of line up. So they're on the same line, right? So if I were to draw a line all the way through these 2 line segments, they would lie on the same line, like that. Okay, so I'm going to redraw these 2 circles so that they have the same chord, right? So here's the same chord. And then I'm going to draw the line. I'm going to use a ruler here for this. So I'm going to draw a tangent so that it's the same line. Kind of line that up here. Okay, I think that should do it. Okay, there we go. Yeah. So you can see how you have this line. It's going to intersect it at 1 point. I'll call that point A. I call that point B. And you could put the arrows on the end. You don't have to, though. It's pretty easy to see that. Oops. Hold on. Problem with ink to shape is that sometimes it changes the B to an O, apparently. All right. Okay, so here's the answer here, and I'll go ahead and... Okay. So the question here is, can 2 arcs have the same measure but different lengths, right? Well, sure. I mean, if a big example is if you have a circle here and a bigger circle here, each of these circles is 360 degrees. But obviously, the distance around this smaller circle is a lot smaller than the distance around that larger circle, and the same holds true for arc measure, right? So you could have that's about 45 degrees, it's about 45 degrees, so that each little section of my circle is the same. But the distance, right, if you were to take that and actually measure the distance, is going to be a lot different. Okay, well, that concludes 1.7. Again, the point of this lesson was to kind of have a common vocabulary to discuss these different geometric concepts, so that when we get into proofs, we get into more problem solving, that when I use words like center and tangent and congruent and concentric, you have a picture in your mind of what I'm referring to, so that I don't have to describe in detail every single thing. It's going to allow us to do a lot more advanced mathematics and a lot more problem solving. And again, part of that vocabulary isn't just the word, but also like what the picture is. So I really want to emphasize that when I say the word chord, to have a picture in your mind of what a chord is. Or if I say diameter, which a lot of you already have, right? If I were to say diameter, a lot of you could visualize what that is. But now, add on the word tangent, add on the word congruent, concentric, circumscribed, inscribed. And definitely be helpful to go through this on your own some more, and maybe make note cards and just have a real good sense of what these are, so that when we move forward into the next chapters, we have a lot of success. So that's kind of the goal. All right. Thank you for listening. Have a lovely day.